Hi, this is Kent Brown, Senior Product Manager at Microsoft. In this walkthrough, I'll demonstrate the Windows Azure Service Bus Relay, a way for you to facilitate communications between your applications and services, whether they run on-premises or in the cloud. If you're not yet familiar with Windows Azure or need additional background, please visit codeplex.com for links to videos and other projects. So let's get started. The Service Bus Relay provides a simple and secure way to do service remoting, exposing on-premises services so they can be called by cloud applications or from your business partners' applications. The Service Bus Relay also supports eventing, or one-way messaging, including one-to-many scenarios where one message can reach multiple applications or services. This creates a way for notifications to be sent amongst disparate and disconnected components in a business process. In this demo, I'm going to show you a sample application consisting of a sender application that communicates with a web service locally or through the Service Bus Relay and sends one-way messages that can be received by one or more listeners. Then we'll have a listener application that listens to all the endpoints, displays all the messages, and responds to the web service calls. I'll switch to Visual Studio and we'll get started. I've set up a simple project that you can download from Codeplex if you want to follow along. The solution file contains a common library, a sender application, and a listener application that can be instantiated multiple times. Let me press F5 and get the applications going. We'll get all the components running at the same time to illustrate the functionality. I've set the project up to build in the proper order and arrange the windows so you can see what's happening. The sender and listener are simple WPF applications consisting of text boxes, labels, and buttons. On the left, the sender sends messages based on the radio button selected: a local web service, a remoted web service through the Service Bus Relay, or as a one-way event. The sender increments counters for each type of message sent and received. For the web service calls, we'll see received messages echoed back from the listener. On the right, the listener listens on a local, relay, and one-way endpoints to react appropriately with the messages, incrementing message counters as messages are received and processed. The listener will echo web service messages, but not one-way messages. First, I'll confirm the sender and listener are functioning properly with a simple local echo test. I select Local Web Service, type Request Message into the left-hand box, and click the Send button. This message is sent to the local web service using WCF and the basic HTTP binding. The listener displays the text I just sent. Then it appends the string local and sends it back. We display the response in the right-hand text box of the sender application. From this, we know the application components are working. Now I'll use the Service Bus Relay. I'll clear the message in the listener, select the Relay Remoted Web Service radio button in the sender, and send the message again. The message travels out over WCF to the relay. The listener receives the call and displays the text I just sent. Then it appends the string via relay and sends it back. The Service Bus Relay provides the means to connect securely over TCP or HTTPS and can employ the access control service to grant or deny access to exposed services. Now let's look at the one-way feature, where a one-way message sent to the relay can be received by multiple listeners. I'll clear the listener text box and select the Relay Event One-Way radio button on the sender. Now I type event message and click send. The listener displays the text I just sent. In the case of one-way, there's no echo back to the sender. To demonstrate how the one-way feature can send to multiple listeners, I'll fire up a second listener. In Visual Studio, I'll right-click the listener, select Debug, and click Start New Instance. Let me position the windows a bit. And I'll send my message again. Both listeners display the text I just sent, and again with no echo back to the sender. Using one-way in your application provides you the capability to initiate actions in other disparate components. As with the service remoting, one-way messaging can employ the access control service on the service bus to grant or deny access to exposed services. With that, the demo is complete. I'll shut down the application and we'll walk through the code. First, I'll touch on what we need to do to use the relay in the application. Relay is a capability of the Service Bus, so you need to create a Service Bus namespace in the Windows Azure portal to use it. Once the namespace is created, you collect credential information from the portal, as we'll use these bits in the code. Now, to use the relay, I'll open the viewModel.cs files for both the sender and the listener. Here, I need to enter issuer name and issuer key values from the portal into string variables. I'll use these later to create relay credentials to access the endpoint. We'll see how easy it is to send messages over the service bus using WCF. We just need to set the right bindings, and WCF takes care of the rest. These bindings would often be set in config files to avoid code changes when moving a service or changing the communication protocol. I set the local binding variable to an instance of basic HTTP binding, and the local address variable to point to my local web service. This enables the local test. Next, I set the relay binding variable to a basic HTTP relay binding, and the relay address variable to the URI from the portal to enable messages to travel over the relay. Then I set the relay event binding variable to a .NET event relay binding, and the relay event address variable to the URI from the portal for my event endpoint. Last, I referenced the Microsoft.Service Bus assembly from the Windows Azure SDK version 1.6 or later. This is in the Windows Azure SDK folder beneath Program Files on your system. The application is ready to talk to the service bus. Let's walk through the code that does the actual message processing. The applications use the Model View Controller or MVC pattern. Let's look at the sender first. The action starts in the main Windows XAML code behind page for the sender, where I initialize the UI and set the data context to the sending main view model object. Looking at the XAML, you see the radio buttons in the UI set binding path variables equal to local, relay, or relay event. The sending main view model will use these values to send messages over the appropriate channel. Let me open the main view model and we'll take a look at the send message function. I'm using WCF to send messages, and I'm using sort of the manual programming technique. I set a WCF channel factory variable, passing in the binding and address, whether local, relay, or relay event. I could easily have used the add service reference method and programmed against a proxy, in which case some of these details would have been stored in the config file. As the relay and relay event messages use the service bus, I need to pass in the credentials I stored earlier. This and the particular binding used is the only difference between sending messages locally and via the relay. Then I create a channel in each case and invoke the method supported by that endpoint. Now for the local and relay functions, we're expecting a response from the web service. In these cases, I create a local variable to capture the response when the message is sent over the channel. When the response comes back, I set the response text box to the return value. Last, I increment my sent counter, close my channel, and increment my received counter. The relay event is a bit different, as I'm not expecting a response. In this case, I simply create my channel and send the message via one way. I close the channel and increment my counter. Now let's look at the listener. Just like the sender, the action starts in the main window XAML code behind page, where I initialize the UI and set the data context to the listening main view model object. Let me open that code and talk through it. For the demo, I set connectivity mode to HTTP. Then I call my listen function. The listen function creates new instances of service host objects, one for each type of message. I add the local endpoint to the first service host and call open. Then I add the relay endpoint to the second service host and call open. Last, I add the one-way endpoint to the third service host and call open. You'll note that for the relay and relay event messages, I make a call to the getCredentials function to provide credentials to the service bus. When the listener gets a message on one of the channels, it hands it off to a message handler that determines if the message is local or relay, is expecting a response, or is a one-way message. The listener displays the message, appending the appropriate text if an echo, or no response in the case of one-way. It increments the proper counters and returns to a listening state. And with that, our code walkthrough is complete. In this presentation, we discussed the benefits of service remoting and one-way event messaging, invoked a web service locally and then through the service bus relay, and sent one-way messages through the service bus to a single and multiple listeners. Give it a try yourself and see how simple the service is to set up and use. The The demo code, scripts, and snippets are all available at codeplex.com. Please also go to windowsazure.com, where you can find the latest information and additional resources, including details of our current offers, information about a free trial, and how to download the SDK. Thanks for your time.